7.5, Sinusoidal Functions. The content in this section polishes off the work of 7.4. We are adding one important new transformation, then using it in applications. While we previously moved sinusoidal functions up and down, a midline shift, and stretched and shrunk them vertically, changing amplitude, two things were constant. The period was always 2 pi. The functions never shifted horizontally. Today, we changed that. On the grid below, graph y equals sine of x. Next, try graphing y equals sine of 2x. Let's think about how to do that. To graph y equals sine of x, we know that when x is 0, sine is also 0. When x is pi over 2, the sine of pi over 2 is 1. When x is pi, the sine is 0. And when x is 3 pi over 2, sine is negative 1. Finally, at 2 pi, sine is, again, 0. So if we trace the curve, we wind up with that. Now, if we wish to graph y equals sine of 2x, some interesting things emerge as we consider our points. I'm going to do it in red. So y equals sine of 2x. If we do the sine of 2 times 0, we still get 0. So our function still starts at 0. Let's try plugging in pi over 2, just like we did before. So sine of, this time, 2 times pi over 2. Well, wait, something interesting has happened here. 2 times pi over 2, the 2's cancel out. This actually looks like the sine of pi. And we know that the sine of pi is 0. So that means that pi over 2 again behaved like 0. What if I plug in pi itself? So yeah, that gave me 0. If I plug in pi, so I'll do 2 times, I'm plugging in pi for x. Well, that's the sine of 2 pi. That was, again, 0. So we need to try some other values. Let's see what happens if we plug in pi over 4. So sine of 2 times pi over 4. Well, cancellation means that this looks like the sine of pi over 2. That was 1. So that means that the sine of pi over 4 behaves like, or the sine of 2 times pi over 4 behaves like the sine of pi over 2. So at pi over 4, this sine of 2x is equal to 1. I bet we're going to get something similar with 3 pi over 4. So sine of 2 times 3 pi over 4. If I plug in that 3 pi over 4, if I get that cancellation, this looks like 3 pi over 2. So that is negative 1. So 3 pi over 4, negative 1. Connect the dots. And there we go. So we have just squished our original function horizontally by 1/2. Change in period. Here's how we calculate it. For the functions f of x equals b sine x and g of x equals, for f of x equals sine of bx and g of x equals cosine of bx, the period is given by 2 pi over b. So for our example of sine of 2x, the new period would be 2 pi divided by 2, which is pi. The whole cycle happens within pi units. And like amplitude, we always express period as a positive value. So even if b were negative, we would still express the period as a positive value. Okay. Determine each attribute for the function r of t equals negative 5,000 cosine of pi over 6t plus 10,000. Big numbers, don't be scared. This is just an interpretation problem. Okay, we just said the period is whatever your b value was divided by, or 2 pi divided by that value. So our period will be 2 pi divided by pi over 6. That is going to give me 2 pi times 6 over pi, which cancel. That's 12. I get one full cycle on this function in 12 units. Who'd have thunk? Okay. The amplitude is going to be the absolute value of our leading coefficient. So the amplitude here is 5,000. And the midline would be y equals whatever your shift was. So y equals 10,000. The next idea is simpler. We're going to graph y equals cosine of x. Then we're also going to graph y equals the cosine of x minus pi over 4. Okay, remembering our values of cosine. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2, it's 0. And the cosine of 2 pi is once again 1. So applying the curve, you get that. Now, cosine of x minus pi over 4. Well, if I plug in the same values, we'll note something interesting happening. When I plug in, let's do it in red, cosine of 0 minus pi over 4, I would have to actually evaluate the cosine of negative pi over 4. I don't really want to do that. So let's try something else. Yeah, I could come up with that value, but let's try something else. Let's instead plug in our next value. Let's plug in that pi over 2 that we were using right here. So I'm going to do the cosine of pi over 2 minus pi over 4. Okay, so pi over 2 minus pi over 4, that gives me the cosine of pi over 4. Okay, so what that is saying is that for my new expression, when we are at pi over 2, we have the same behavior as when we were at pi over 4. So if I was up here at pi over 4, that point now looks like that. Well, maybe there's an easier way out of this. Let's actually plug in pi over 4 itself. If I do the cosine of pi over 4 minus pi over 4, that's equal to 0. No, it's not equal to 0, is it, Nathan? It's equal to 1. So that means that my original starting point here has been moved over here. It's been moved over to the right by pi over 4 units. And all of my other points are going to follow suit. Let's look at this. Yeah, if we were to plug in 3 pi over 4 and then do the minus pi over 4, this looks like the cosine of pi over 2. So that means where I was formerly living right there is a 0. Now it happens at 3 pi over 4. So if we were to trace this preliminarily, it looks like our whole graph just got shifted right by pi over 4. And in fact, that's exactly what happened. So my new minimum value will now be at 5 pi over 4 because 5 pi over 4 minus pi over 4 was pi. My next 0 will happen at 7 pi over 4, and then my endpoint of the function is going to be off the graph. That is what we are now dealing with. So this is a shift right of pi over 4. Horizontal shift. For the functions f of x equals sine of b times x minus h and cosine b times x minus h, the horizontal shift is given by h. This formulation with parentheses is very important. Okay. Determine each attribute for the function for cosine of 3 times x minus pi over 4 plus pi. And we're asked for the period, the amplitude, the midline, and the horizontal shift. Well, let's start with the easy ones. We know that the amplitude is going to be 4. We know that the midline is going to be pi. Based on what we did up above, the item being multiplied by x is 3, so I think we can get the period by saying it's 2 pi over 3. And I'll tell you that is, in fact, correct. Now, what's the horizontal shift? Looks like the horizontal shift here is right by pi over 4. But this is incorrect. And here's why. Look at the way that our original functions use parentheses. I said that was important. In order for this term to represent the horizontal shift, we already have to have factored out whatever that leading coefficient on x was. So let's do a little bit of a rewrite. 3 times, and let's make parentheses, x minus, if we factor out a 3 from pi over 4, we will have pi over 12. And that is what our actual horizontal shift is. This is, in fact, right by pi over 12. Finally, an interpretation problem. We're going to build a function based on this information. Find a function that has a midline at negative 500, a maximum value of 1500, and a minimum value of negative 2500, completes one cycle in 24 units, and contains the point 0, 1500. Should we start with sine? Should we start with cosine? Heck, let's just start with sine. So we know that our basic form is that it'd be a times the sine of b times x minus h plus k. Okay, let's see what we can go ahead and add in here. Well, we know that the midline is negative 500, so I can make this y equals stuff times sine of stuff times x minus stuff minus 500. And I'm going to try and fill in the rest of these. A maximum value of 1500 and a minimum value of negative 2500. Well, if we're running from 1500 down to 2500. We could do a couple of ways, right? We could look at the midline and look at those points, or we could just say 1500 minus negative 2500, which is equal to 4000, and divide that by 2. And note that the amplitude would be 4000 divided by 2, which equals 2000. So amplitude of 2000. Let's look at the rest of this. Completes one cycle in 24 units and contains the point 0, 1500. Okay, one cycle in 24 units. This speaks to our B value. It doesn't say that B would be 24. It says that 2 pi divided by B would be equal to 24. So that means that B must equal 2 pi over 24, which would be pi over 12. Okay. Now, we're told that this contains the point 0, 1500. 0, 1500. So the question comes to mind, does this describe a horizontal shift? And where have we seen 1500 before? Well, 1500 was our maximum value. And if our maximum value happens at 0, it's probably better, rather than describing this with a horizontal shift, to describe it with a function that has its maximum value when x is 0. And that function is not sine. That function is cosine. So we will make this the cosine of pi over 12, and we will say that h was 0, that we didn't need to worry about a horizontal shift. So if we wanted to come up with a nice, clean, final compact form, we would say y equals 2000 cosine of pi over 12 x minus 500.